Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Hager number BB1191 ETW 4.5, 26D. This is an electric transfer or electric pass-through hinge. Basically, electric transfer wire hinges, electric pass-through wire transfer hinges. They just simply permit low voltage to come through the hinge and do so in such a way that is most certainly to the casual observer completely indistinguishable. Okay, from the front you don't know that this is a hinge that has wires running through it, and the way that that's done is these wires, very small holes are drilled in the edge of the hinge leaves, and wires are basically fished. Very thin wires are permitted to be installed through here. The barrel is compromised in such a way that it will give a raceway for the wires to transfer through. So let's dissect the part number a little bit. This is a very typical hinge. This client, looking at his order, what the client's doing is they have a mortise lock, that is fail secure, I'm not exactly positive of the function of the lock because I don't have the function number memorized, but obviously through via some sort of access control perhaps, or maybe just something as manual as a push button, is going to allow that lock to temporarily close the circuit, temporarily operating the lock. Well, you need to get the wires from the wall through the frame into the door to the mortise lock, and this is an elegant way to do so. Okay, this is a 4-wire hinge, and that is in the part number, the ETW4, electric through wire 4. You can do this with more wires. 12 might be the limit. If you needed to have more wires as a result of more electrified control over the lock, an example could be where you are running a 4-wire hinge will be the minimum that you would get. You wouldn't get a 2-wire hinge because this gentleman's lock, yeah, it is a gentleman, is just requires the ability to temporarily unlock the lock. That could be, it's not electric latch retraction, it's just going to allow the exterior trim to operate while the circuit is closed. You only need 2 wires for that, but there's 4 because that's normal. You have an extra pair at a minimum should something get crimped. These are 28 gauge, which in wire gauge speak, they're quite thin. As a result, they'll only handle so much amperage going through them. But why would you possibly need more wires? Well, you could simply, if this gentleman's mortise lock had a REX switch, a request to exit switch on the inside lever, where you rotate the lever and the micro switch is temporarily closed, and that reports back to something. Maybe it's letting a lock, maybe it's telling a lock to release, maybe it's setting a entry in a database in an access control system, whatever it is. It could be an annunciator. It could be making a sound when someone rotates that lever. What if, so that would certainly require a 6-wire hinge probably. What if you then had latch bolt monitoring on it where you wanted to know if somebody was loading the latch bolt? You need some wires for that. Okay, so on and on. If you were doing, you get the point. The more features you add onto your electrified hardware, the more wires you need for it, obviously. And this would be a 4-wire version. So let's dissect the part number. This is UL listed. Okay. Indicated as such. This would be permissible for use on a fire-rated door. Okay. Dissecting the part number. First of all, it's a BB1191. That in Hager speak is a ball bearing hinge. 1191 means a number of things. First of all, it means that this is a non-ferrous base material. 1191 for Hager is either going to be a brass or a bronze or a stainless base material. This is in, they call this 20, this is actually, let's back that up, way up. This is not permissible for use on a fire-rated door. That UL listing is probably just listing the fact that this is a electrical listing. Yeah, I've misread that. This is not permissible for use on a fire-rated door. Certainly why? It's non-ferrous base material, and it is not stainless. You can use stainless steel base or steel base on a fire door, but the clients ordered 626 on this hinge, which means satin chrome, which also means brass base material. So this door is definitely not fire-rated. Ball bearing, that means that there are 2 bearing packets because the 1191 means it's a standard weight hinge where it's 134 thousandths leaf thickness. It means it's a full mortise hinge. You can see from the swag on the hinge leaves here and here that when you bring the leaves parallel to each other, they're meant to be mortised flush to the edge of the door and frame. That's what a full mortise hinge. It also means it's a 5-knuckle hinge. Okay, it means also that it will have a template pattern on the screw holes. That will be a standardized pattern for screw holes. I'm not sure when the template pattern was introduced. Mid-century? I'm taking a stab. It is definitely mid-19th century, absolutely. That would have been probably introduced, although something tells me maybe the late 1960s. The point of the matter is if you're dealing with a 4.5-inch tall hinge that has these holes, it's very likely what we would call the template pattern. The word template refers to the fact that I can show you a technical drawing of this hinge, and we'll call it the template, or I can use the term template to intend to describe the precise and exact dimensional locations of all of the holes. Okay, if I say it's a template pattern 4.5-inch hinge, you can buy a hinge from anyone that meets that requirement, and it will fit into your door and frame. Preparations for screws is the bottom line. So this is also a 4.5, 4.5. This hinge is therefore 4.5-inch tall and 4.5-inch wide. It's important to know the width is the first dimension on a hinge like this. Just know that the height is absolutely the first dimension. It's not 4.5 wide and 4.5 tall. It's 4.5 tall. That's important because you may have a electric transfer hinge that's 5 by 4.5. You certainly could have that. Or a 4.5 by 4. You could certainly have that. So you need to know what is the first dimension, and that being the height. That's why that's important. Now, we'll get to the extended description information. What's nice about this hinge is that it's rated for 3.5 amps continuous, and it will take a 16 amp pulse or a very short microsecond type inrush. So it will handle a huge amount of amperage, which some solenoid driven electric latch retraction exit devices have this huge inrush, and there's been a migration away from solenoids to motorized control because the motor control sips electricity, where solenoids are not as efficient in that regard. The wire gauge is 28, and then basic hinge information. If we took away the wire, the electric transfer, it becomes a BB1191. It's just a regular non-ferrous base material, good old-fashioned full mortise hinge. You can't modify these. You can't do anything to it. Don't try to dimensionally change anything. These wires are literally passing through this hinge. This is not a load-rated hinge as well. Absolutely locate this in the middle location. And if you have a door with 4 hinges, I would like it to be from the second from the bottom. The hinges located at the top of the door do the majority of work of hanging the door, but so you don't have a load rating on a compromised hinge. It's not compromised in the fact that it is no longer capable or sufficient. It's intended now to do a different job. Its job is not carrying a load. Its job is allowing you to transfer electricity to a load, okay? To a lock from the switch, okay? So be mindful. This includes, okay, this is really important. you're getting all machine screws and half wood screws. Every manufacturer, every time I review one of their hinges, I get all wood screws, all metal screws. I get, all machine screws. I get half wood screws. What screws do you need? Will you get them when the hinge shows up? I very much recommend that you indicate at the time of order in the comment field above what the composition is of your frame and your door, so you can get the proper screws. It would be unlikely that this would be a wood door and a wood frame, but it certainly wouldn't be unheard of. I happen to know that this isn't, but if this client, you will get a call once or twice a year, I didn't get enough wood screws. What do you mean? There's half wood screws in the package. Well, yeah, I've got a wood door and a wood frame. Okay? Wood door, steel frame, very common. Steel door, steel frame, very common. But what happens when it's wood by wood? So just define. We don't want you to not get enough screws. That's just a hassle. These are 12 by 1.25" flat Phillips threaded to the head wood screws. That exact thread size, type, length, everything is actually defined in NFPA 80 as the mandated screw for hinges when they're used on fire-rated doors. 12 by 1.25" flat Phillips. Phillips doesn't matter. I don't believe the standard. It's not a code. The NFPA is a standard. It becomes a code if it's adopted in the local building code, which it is. Threaded to the head wood screw. So let's switch to the screen view and take a look at the supporting documents for this hinge. Now here is the item that we're looking at and supporting documents, and let's get to the first one. It's going to be called ETW instructions, and this document will be included with your hardware, but this is used for the 4, 6, 8, 10, and 12 wire version. Okay, steel hinges for interior, brass and stainless for interior or exterior. They should have steel for interior, stainless for non-fire rated and fire rated interior use, brass for exterior non-fire rated use, stainless for interior or exterior fire rated or non-fire rated use. That's how I would amend that. They're going to want to be sure that you have a mortar box on the back of your hollow metal frame. How you're going to go about ultimately, if you're the frame supplier, you need to think about what position you'll put your client in terms of how are you going to send out the frame. Will you do nothing other than drill the hole in the back of the hinge reinforcement and leave the rest up to the contractor, which would be very common and typical? Or will you go so far as to install conduit according to the requirements, giving your client a much better chance of getting the hinge wiring installed in the proper place? So communication about that will be required. The point of the matter is you can't let mortar hit the back of 28 gauge wire, which can't be is not very thick, is the bottom line. Electrical rating: each wire is rated at 50 volts, 3.5 amp max, continuous, or a very small inrush pulse. Maximum pulse time 400 milliseconds. Minimum off time between pulses is 10 seconds. Now, this will help you know what you're dealing with in terms of your wire colors, should that be interesting to you or information of value. 4, 6, 8, 10, or 12 wire, they're all color-coded here. Door and frame must be prepped accordingly. Through-wire hinges are not load-bearing and must be mounted in the center hinge position only, or if you've got doors that are taller than 7'6" and you get into 4 hinges, I'd put them at the second from the bottom. Do not attempt to disassemble the hinge. Don't do that. They are not meant to come apart at all. Wire access holes must be free of burrs and sharp corners. That means when you drill the hole in the door in the frame, be sure that nothing will snag your wires. There is a thick, durable, clear coating, or slip sleeve, I should say, that the wires are passed through to protect them. Open door to 90 degree or more for access to jam preps. Sure, okay. Extract interior wiring through the prep holes from the door and frame. Terminate wire connections with appropriate crimps, splices, wire nuts. It is helpful to stagger terminations. This allows for easy insertion of wires through prep holes. Basically, I think what they're saying is when you are using wire nuts or, connecting your wires, stagger those connections so that you can fold the wires back through your prep hole a little bit easier, rather than trying to stick, possibly 2, 4, 6, 8, 10 wire nuts through a prep hole. Wire gauge is 28. For current ratings larger than an amp, double up your wires. Okay? Maximum total current for a 4-wire hinge is 2 times the maximum current shown in the electrical ratings chart. Okay? And if you need to get even crazier, okay, you can continue on those wires. So that is the ETW installation instructions. Back at the item that we're looking at here, there's a template, which we can take a look at. This is going to show you where your prep hole needs to be in the door leaf and the frame leaf to get your wires passed through. I don't know why. I bet that there's more than one prep happening on this hinge. ETW. Okay, so let's look at what Note B says. Drill and deburr a 3/4 inch diameter hole for 4 through 8 wire hinge, or a 13/16 hole for 10 to 12 hinges. Okay, so what they're saying is if your quantity of wires is between 4 and 8, you're going to do the B hole. If you get beyond that, you're going to need to give more room, which will give you this 13/16 hole here. Okay, don't do both. They're saying or. You don't need both preparations. Be sure to deburr the holes, clean that off. Here is your frame prep. That's going to be Note A, probably a 1-inch hole. Drill and deburr a 1-inch diameter hole in the frame to pass your wires through. Okay. Electrical characteristics, again, are listed here. The hinges that this applies to are here. Your steel hinge standard weight, your steel hinge heavyweight, standard weight non-ferrous, heavyweight non-ferrous. The locations, here's our template locations. The location of your screw holes, that's a constant on a template pattern hinge, and that will allow you to understand where all that is. The last document, the last supporting document we have is our product catalog, and that will give you an overview of Hager hinges. BB1191, that's not coming up because it's not searchable, but here it is. BB1191. Brass with a stainless steel pin, or stainless with a stainless steel pin. So no bronze. It'll be brass base or stainless base on that. Wide throw versions, heavyweight versions. Here would be your heavyweight version of that same hinge, an 1199. The difference there is that your leaf thickness is going to go up by about 50%. Depending on the height of the hinge, it'll be 180 or 190 thousandths or 203 thousandths, as listed here. Okay. The height is really important, as I had said earlier, because the height has a lot to do with the load that the hinge is capable of. And it would be considered, I think, best practice if you had doors 3'6" and wider, where you abandon the common 4.5, 4.5, and you go with a 5x4.5. Lots of instances a 4-inch wide would be a better choice when you don't have any clearance that the hinge needs to get the door out and around. So be mindful to use a 4-inch wide hinge every time that you can when it makes sense. I've done projects where we're doing 4080 doors that are hung in welded frames. I'm using 5x4s, and where that comes into play, people will say, well, why don't you use the 4.5-inch wide? Well, it's not best practice. Here's the bottom line. You've got a big giant wall, and you're going to have that frame right here. Okay? How far out that knuckle needs to reside is directly related to, okay, the width of the hinge. And in a scenario where you're butting, your frame to the wall, yeah, you've got to think about what is the requirement of the width of the hinge. But my project where I did 4080 5x4s and a heavyweight, I'm dealing with kind of drew that wrong, but no, never mind. I'm dealing with wraparound. Okay, that dimension of my hinge, my vertical axis of pivoting, I want as close to the face of the jamb and door as possible. I don't need to have that hang out here. You don't want that to hang out any further. So I've got a 5-inch hinge that's 4-inch wide, 5-inch tall hinge that's 4-inch wide. Best practice because it brings that vertical axis of pivoting closer back to the face of the frame, which is, from a mechanical perspective, a more efficient way for your door to swing because I'm bringing the entire load of the door, the weight of the door, closer to its center line. Now, not much, but it's considered best practice. It would be mechanically more efficient to do it this way. So you can do a 5x4.5. I don't think you're going to be, cited for it, but it's not best practice. Okay. Now that wraps up this video, I think. Obviously, you're going to be able to do this in lots of different finishes: polished brass, satin bronze, oil rub bronze, satin nickel, polished chrome, satin chrome, etc. Let's wrap up this video on camera. Very nice quality hinge. Hager has about a 170-year head start in manufacturing architectural hardware. I don't know the year that they started, but it's certainly mid-19th century. I was quite fortunate enough to be in an advanced hardware detailing class with the head of specification writing for Hager, an absolute inexhaustible source of knowledge, incredibly generous with his knowledge, skill, time. I was instantly better the moment I entered that classroom every day for 5 days. The name Hager is quite synonymous with hinges. It's their namesake, Hager Hinge. If you know Hager for anything, it would certainly be for a hinge. However, don't pigeonhole them. Hager manufactures everything for the door opening except the door and frame itself, and I have often thought Hager must be working on the door and frame as well. Hinges, lock sets, exit devices, electrified hardware, obviously, to go along with the ability to transfer it. Door closers, continuous geared aluminum hinges under their Roton name, every conceivable type of residential, commercial, institutional, architectural hinge, weather stripping, trim and auxiliary, sliding door hardware, builder's hardware. They have a European line of material. There is a link below this video to the manufacturer's page where you can pull up not only all of the Hager products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. Any questions on the Hager? This is their part number BB1191, 4.5 by 4.5, and a US, it's a 626 finish. They're not using the BHMA code here. They should. I would like for them to do so. The U.S. system was put into effect at some point in the early 1930s. Hager was a senior citizen by that time. That new, happy-go-lucky system came into play. They're still using the U.S. system. The U.S. system versus the more accurate BHMA system is US26D, well, it tells me satin chrome, but doesn't tell me what the base material is. If I called it 652 or 626, I know they're satin chrome. 652 is made of steel. 626 is non-ferrous. That could be brass, bronze, or stainless. In this case, it wouldn't be brass, bronze, or stainless. For Hager, it would be, but in this case, it would be brass base material. Okay, there is not a. Oh, yeah, there is. If this was a BB1191 in a stainless base, it would be 629 or 630. So the BHMA code helps us understand beyond what Hager is doing here by telling you it's non-ferrous. But if they tacked on the BHMA here, then I'm going to know what non-ferrous it is. Is it brass or stainless? Anyway, there's obviously a reason for it. Any questions on this exceptional hinge or any other Hager product, please feel free to reach out to us. And thank you.